just going to work through a few more equations, and again, you may want to stop and pause along the way just so you can try them on your own and then see how you did. So the first one we get to, again, I'm going to, at least part of the time, go through these pretty quickly because I don't want to spend a ton of time talking about form, but it is important here, and one of the biggest things that's important, of course, is that it's equal to 0. So we see that we've got a binomial. The exponent is bigger than 1, and it's set equal to 0. So that's how we know we've got a quadratic in form equation. So we look at p squared minus 100. We see it's a binomial. We know that that is a binomial square. Notice how I bring that 0 with. And of course, the perfect squares, we just do our variable, and then the square root of that is 10 and 10. And then we just do a plus and a minus. And of course, our next step is to take each term and set it equal to 0. And we can see very quickly, p is negative 10 and p is positive 10. So there are our two solutions. Now let's look at this next one. And the next one again is perfect squares. I'm going to go ahead and do our double paren equal to 0. Square root of 64, square root of x squared, square root of 81, plus minus. And now we take each of those terms and set it equal to 0. A little bit more complex. I'm going to set them off here. So I subtract 9. That leaves me with 8x is equal to negative 9. Divide out the coefficient. I'm just solving regular equations here. I got my 8, there we go. So 8x is equal to 9, again dividing out the coefficient. So x is equal to negative 9/8 and positive 9/8. Let's look at the next one. Again, a binomial. And we see that we've got a greatest common factor of 5, so we take the 5 out. And when we divide 405 by 5, we get 81. And now we see that this new binomial that we have here is the difference of squares, square roots, and then we do the plus and the minus. We see that our first factor is a constant, so there's nothing we can do. The next two we have x plus 9 equals 0, x minus 9 equals 0, and then of course we solve for each, and we get our solution. So x is positive 9 and x is negative 9. Now the next one that we have here we see we've got a greatest common factor again, and this time it's a variable. So we pull that out. We're left with x squared plus 24x plus 144 is equal to 0. You'll notice that I never leave the 0 off because once we've got that going, we can't stop it. And now we see inside we've got this lovely trinomial that we can probably do something with. So we bring our greatest common factor with. This is a trinomial with a leading coefficient of 1. It's something special too, but most of you probably just want to focus on doing it this way because it's almost always easier. What are the factors at this point anyway? What are the factors of 144 that add to 24? And of course that's 12 and 12. Signs are the same, both positive. So we could rewrite this as x, and that really helps us see that we do have two factors here, two unique or different factors. So we take each of those factors and set it equal to 0. solve that one. So we get x is equal to negative 12. And of course there's nothing we need to do with this one, so we've got x is equal to 0 and x is equal to negative 12. Okay, so we've got, let's see, 2x and 4x. We want them to add to 14. So if we do our little loop here, we have the 4x and then we do the outer one and we see that we've got the 10x. So we know that we're good. Again, the second sign tells us signs are the same. The first sign tells us they're both negative. So now we've got it in factor form. We take each factor, set it equal to 0. And of course, now we solve. Divide by 2. So we've got a 1/2. I'm going to have to rewrite that because it's a little messy. Plus 5. And divide by 4. So we've got x is equal to 1/2. And we've got 5/4. And of course, we don't care that that is an improper fraction. Just leave it alone. So now let's look at our next one, and the next one has the greatest common factor. You can see that there's a variable in each one, so we can take out the variable. There's no numerical greatest common factor. 2 doesn't go into 5 evenly, so as soon as we get there, we know that that's done. And we just divide each factor by x. Always remembering to bring our equals 0 down with. And now we're going to try to factor our new trinomial. And 12 doesn't have that many choices. But we do have to decide which one we want to go with. Again, using whatever tools you need in your own time. I'm going to go ahead and remember this is telling us we need to subtract to 5. So I'm going to go ahead and put the 4 here and a 3 here. Again, that means that the signs are different, so our products are supposed to subtract to 5, and 8 minus 3 gets us that. And that second sign, remember, also tells us that the signs are different. And this sign tells us what the bigger product is. So the bigger product is 8. That means the smaller product is negative. The 3 is the negative. And then we just place the signs properly in the new parens that we've created. And now we've got 3 factors. So we set each factor equal to 0. And solve. Again, using the same skills that we were using a long time ago. At least it feels like a long time ago. So now we see that we have 3 solutions. X equals 0, x equals 3/2, and x is equal to negative 4. All right, so let's do this one, and we see that as we look at this, it's in proper form. Set equal to 0. We know we're looking for a couple solutions. There's our exponent clue there. And now we are going to look for GCF. We see we have one, so we divide it out. And now we know we want to see if we can factor the trinomial here a little further. So it's a leading coefficient of 1, so we know it's just x and x. And then we, of course, ask ourselves, what are the factors of 5 that subtract? The factors of 6 that subtract to 5, and that is 6 and 1. The signs are different. The bigger product is negative. And we're factored. And now we've got 3 factors, but we notice that our first factor is not a variable factor, so we don't have to worry about it. So we just take the 2 factors that have a variable in them and set them equal to 0 and solve. And there are our 2 solutions. And let's just finish out with maybe just a couple more examples. And remember, pause this as you want to so you can do them before we start working them. So here we have, again, an equation. It is quadratic in nature because an exponent bigger than 1. And so that means it's set equal to 0. So it's in proper form, so that's all good. It's a trinomial with a leading coefficient of other than 1. Again, use whatever method that you want to solve these or to factor these first. I'm going to try 3x and 2x. And remember, I want these to add to 11. I'm going to go ahead and put in 4 and 1. And this tells me the signs are the same, that they're both negative. So when we do the math here, negative 8x, negative 3x, there's my negative 11x, so I know I've chosen my numbers well. And now all I have to do is take each factor and set it equal to 0 and solve. Divide out that coefficient. And there's my first solution. Again, divide out that coefficient. And we're good. Let's do one more. And here we see that we've got 9x to the 4th. That x to the 4th tells us that we probably need to look for a variable greatest common factor. And sure enough, there's an x in each term. And the smallest is the x squared, so that's what's going to come out. We also have a pretty significant coefficient here of 9. We've got 33. We've got 18. And then, of course, you're going to want to spend some time figure out what's the biggest thing that goes into all 3 of those. And, of course, hopefully you did that and you found that 3. And I divide that out. I get 3x squared plus 11x plus 6. And now I'm going to try to factor this one further. You can take as much time as you need to do this. And we can see that we are trying to add to 11. So the signs are the same and they're both positive. So we're trying to add to 11, so we'll go ahead and put the 3 and the 2. Signs are the same, both positive. So now we've got our 3 factors. Now we looked at this and we thought, we might have 4 solutions. So we'll take each factor, set it equal to 0. So 3x squared is equal to 0. Well, okay, divide by 3. I'm going to do this the long way. X squared is equal to 0. Then we take the square root of each, and we've got x is equal to 0. So we kind of did the long way there, but there you go. And then we'll take each of these other factors. 3x plus 2 equals 0, and x plus 3 is equal to 0. Solve. And last, of course, dividing out that coefficient. There's my second solution. Getting that variable alone. And there's my third solution. So in this case, it had 4. But again, remember that that changes as soon as you have a variable that's squared. So that's what makes it kind of go less than what we expect, or the fewer number of solutions than we might normally expect. So go ahead and you want to practice the heck out of these. This is going to be a good place for you to really practice factoring, in addition to starting to get really kind of good at our quadratic equations. Now, when you get to the next class, you're going to learn the other three methods to solve quadratic equations.